Hello, welcome. Hope your lunch was great. Please make sure that you guys are paying attention, staying quiet, and copying down these notes. I'm going to go through these a little bit slowly so that as I put this up here, you should have plenty of time to listen, copy this down, and take notes on what I'm putting up. Okay, so it's going to be a review today. We are going to once again go over the concepts that we covered for the last test that we took, and we're going to do each one of these. So please, again, take notes as I'm doing this. Stay quiet, stay focused. Don't distract others around you so that they have the opportunity to get a higher grade. Okay, should be about finished up tiling your notes. And here we go. Okay, first part, determine whether the relationship between the two quantities described in the table is linear. And by linear, I mean if we were to graph these coordinates, they would create a straight line. They would make a line. So let's go ahead and make a table. Let's do it like so. And let's do hours worked, money made, okay, and so for the first one, for the hours worked, let's do hours worked, let's do 4 hours. And money made, let's say the money made in those 4 hours was $2 amount here, $200. So worked. Actually, let's change that. Let's do $60. Okay. So hours worked. Money made was $60. And let's keep filling in our table. So 4. Let's do 6. Let's do 8. And let's do 10. Okay, for the dollar amount, let's just make it 90. Let's do $20. Let's do, I don't know, $150. Sound good? We're good? If you said no, sorry. Sound good to me. So we'll do that. Okay, so go ahead and make that table. And we want to know, determine the relationship between the two quantities described in the table as linear. So I need to figure out is there a relationship between these two numbers. And to do that, all we have to do is take the output. So this is like your x coordinate. This is your y coordinate. To find the relationship, you take the value of y divided by the value of x. So it's output divided by the input. Okay, so when I made $60, hours worked $4. So I'm going to do a new page here, and I'm going to do 60, and I'll divide that by 4. Okay, 4 goes into the 6 one time. 4 times the 1 is 4. 6 minus 4 is 2. Bring down that 0, and I got 20. And I do 4 goes into 20, I believe it's 5 times. 4 times 5 is 20, and that was correct, 0 left over. So 4 goes into 60, 15 times. So let's go back here. So our relationship here was 15, and we did the 60 divided by 4, so that's $15 per hour. Okay, so I want to check this and see, does this work for the rest of my relationships? The rest of 90 divided by 6, 120 divided by 8, 150 divided by 10. I need to see, does this work for the rest of these numbers? So I just continue to do this for the rest of them. 90 divided by 6. Let's go back, erase that. And do 90 divided by 6. And 6 goes into 9 one time. There's our 6. 9 minus 6 is 3. 3 is less than 6, that's good. Bring down our 0. 6 and a 30 goes in and even 15 times. Because 5 times 6 is 30, and it leaves you with nothing left. Okay, so this was also 15. Okay, so this one's the same as this one. So what we need to now see is 120 divided by 8 also going to be 15. So let's take our, let's erase that. And take my 120, I'll divide that by 8, and 8 goes into 12 one time. 12 minus 8 is 4, bring down to 0, 48 goes into 45 times, and that is our 15. Okay, so that works. And hopefully we can do 150 divided by 10, that equals 15 as well. That also works. So, determine the relationship between two quantities described in the table is linear. It is. So it is a yes. So I would write yes. It is linear. Because as I divided each of the outputs by the input, I got a relationship of $15 per hour for each and every one of these. Okay, so that would also be constant rate of change. And for this problem, it ended up being, when we took our dollars divided by the hours, we got a number of $15 per single hour. Okay, so was it linear? Yes. What was the constant rate of change? Constant rate of change was $15 per hour. Okay, whereas if I had gone through this and it was not 15 for each one of those, and it wouldn't be linear, and then there also would not be a way to find a constant rate of change because there wouldn't be a relationship between them. So, not like this. This one did have a constant relationship that was $15 per hour for each and every one of these 4 sets. Okay, next part. Finding the slope of the line that passes through the points. Okay, so there's my text. Let's make that larger. So let's make that larger. So make that small. Okay, so find the slope of the line that passes through the points. And now, we're just given 2 coordinates. Let's say with coordinate A, 2 comma negative 3. And B is going to be negative 2 comma 3. No, let's do negative 4 comma 6. Okay, so write this down. Make sure you guys are keeping up, paying attention. Cordell, turn around, make sure you're watching this. Okay, hopefully that's been enough time that you guys have read those instructions and you've copied down those 2 points. If that's not enough time, make sure you guys are keeping up, paying attention, not turning around looking to see what others are doing, and staying on task here, okay? And I'm going to show you the 2 ways to do this. So I'm going to take this point. I know that I'm going to need to find the slope, so I'm just going to rewrite it up here. And if you remember the equation, it was y2 minus y1 divided by x2 minus x1. And you probably wonder what I'm doing here. Probably looks like I have no idea, but I'm going to write a 2 here, and 1, 2 here, 1, and then here's my division. Okay, so again, remember that slope is the difference in the rise divided by the difference in the So it's rise over y. Okay, so it's y is always on top, x is always on bottom. So let's just label these x, y, and I pick either this point is point 1 or this point does point 2. In the end, it doesn't matter which one you pick as long as both numbers here, the 2 and the negative 3, are both point 1 or they're both point 2. So let's just go 1, 1, and make this 2, 2. Okay, so now I need to go and I'm going to find out what is my y2. Okay, look over here. Yay, there it is, y2. It's on the second point and it's the y value. Okay, so y2 is 6, and then I have my little minus sign here, so 6 minus, and my value for y1 is a negative 3. Okay, that's all being divided by x2 minus x1, so I come back over to the second point, x2, I write down negative 4, minus x1, which is a positive 2. So, problem here though, I have minus and negative. Anytime you're subtracting a negative, that's changing to plus, so it's 6 plus 3, which is 9, divided by negative 4 minus an additional 2. So think of it on the number line. Here's 0, that's a terrible number line. Negative 1, negative 2, all the way down here to negative 4. If you're at negative 4 and you're subtracting 2, you're going this way. So that's going to turn into a negative 6. And I'm thinking of a number that goes into both 9 and 6 because I can reduce this. That number is 3. So 9 divided by 3 is 3. And 6 divided by 3 equals 2. So our slope for this equation, I can't reduce it any further, is 3/2. Go ahead and leave it as a mixed number. Do not change that to 1.5. Leave it as 3/2. And hopefully some of you guys are telling me about the mistake that I just made on this here. And that is that I didn't make the entire thing negative, because here it was a positive divided by negative. So this is going to be a negative 3/2. Okay, so the answer is negative 3/2 for your slope. Okay, so an example of how you go from 2 points to find the slope. Now I'm going to go back and show you the other way. So if you're just completely lost, you can't figure out that formula, study it, review it, work on it, try to get that down so that for future stuff you can't get that. Okay, so I'm going to go ahead, I got a formula here, I got my points, see if I got some graph, yes, I got some graph. Score. Okay, let's graph our 2 points. A, make that the black point, B, make that the blue point. Okay. A is at 2, negative 3. So start at 0, 1, 2, you go down through 1, 2, 3. Okay, for B it's a point that's negative 4, 6. So from 0 you go negative 4, 1, 2, 3, 4. Positive 6, 1, 2, 3, 4, 5, 6. Okay, so these are our 2 coordinates. What we need to figure out is what is the slope. So going from here down to here. I need to figure out my rise, and I need to figure out my run. My rise is vertical, so from there to there. And then my run is horizontal, from here to there is your run. Okay, let's figure out what these numbers are. Okay, so the run, going down. Let's do it. Okay, so from there, okay, so I got my little pointer. So from there it's going down 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went down 9. So far for my slope, n equals negative 9, and it's going to the right. So start here, that's 1, 2, 3, 4, 5, 6. So down 9, and then to the right 6. You can reduce 9 over 6, divide both of them by 3, and you get 9 over 3 is 3, 6 over 3 is 2, the whole thing is Okay, so that's using a graph, and that's also using the formula. So those are two different ways that you can find a slope. Okay, moving on to the next question.